Yeah, everyone got this page?
Yes.
Sir, 1 minute, my internet is unstable. I'll just come in 1 minute.
Okay.
Yes, sir, continue.
Now see separation method. The first method is this is for applicable for and a solid that is insoluble. This method will be filtration. Okay. So we are just going to note down the method of separation. This is the first method of separation. This is used for insoluble solids. So this is the method that will be used. Okay. The liquid part that drips down, this is known as filtrate. The solid part that remains in the filter paper, that is known as the residue. Stop talking. Okay, so this is the method that is filtration. We'll just write this down.
So we have to write this now.
Yeah.
So do we have to draw the thingy?
No, that's not necessary. Just understand how it is done.
Okay, sir.
Yeah, everyone has finished. We can go ahead.
Yes, sir.
Next part is for soluble solid plus liquid. Now it depends because there are many different methods for a soluble solid in liquid. I can consider simply an example of salt plus water. Salt is NaCl. Now here different methods are there that are used. If you want the solid part, then you can use the method of evaporation. Okay. If you want the liquid part, okay, this is evaporation to obtain solids. Then even if you want this solid in the pure form, more pure variety, there is another method, that is crystallization. And if you want the liquid part, that is if water is required from here, then you can use the method of distillation. Just copy down all whatever is there on the screen. Yes, everyone has finished writing all of these.
Yeah, sir.
Yeah, sir.
In evaporation, we are just evaporating the liquid part, so it is left just in open space. So the liquid part that is there, that is generally water. In this particular example that we have considered, this is how we get salt from salt pans. Okay, so the water will get evaporated. What will be left behind will be salt. So this method is evaporation. We are where we are obtaining a solid. Now crystallization is a special technique where we are obtaining this salt in more purer variety. Okay, so I'm just going to show you the experiment of crystallization and how this is going to be performed. Are you able to hear the audio? One second,
No,
I'll
sir.
check. Wait 1 minute.
Fred, a saturated solution of copper sulfate and copper sulfate. First, we will make a supersaturated solution of copper sulfate. Light the spirit lamp, place the copper sulfate solution on the burner, heat the mixture. Now keep on adding copper sulfate till no more salt is dissolved. Fasten a thread on a support and suspend it in an empty glass. This thread will act as a nucleation center in the container. Now remove the solution from the burner. Pour the solution in the glass. Leave the glass aside for a few days. We see salt crystals formed on the string. This happens because the solubility of salt in water increases with temperature of solution. So more salt gets accommodated in the solution than it would have if water was at room temperature. This solution is called a supersaturated solution. The salt from this supersaturated solution gets precipitated out when the solution returns to room temperature. The salt molecules that get precipitated out start forming crystals at the nucleation center, which is the thread in this case. Crystallization is the process of formation of solid crystals of a substance by precipitating it out from a saturated solution.
Please write down the definition of crystallization. Yeah, everyone has finished the definition. You can go ahead.
Yes, sir, finished.
Let's go ahead now.
Why don't you try making sugar crystals at home?
Next method is distillation. This is
Distillation. Distillation is the process of heating a liquid to form its vapors and then condensing the vapors to form the liquid.
just write down the definition of distillation.
So done.
Okay, this is the distillation apparatus.
Brown bottom plus. No? Distributor. Distillation. And so we go. Bono. Cork.
Okay.
So tripod stand.
Yep.
So do we need to?
Yeah. Just make a note of this. You can just draw a rough freehand diagram and then just label everything whatever is over here.
Oh God. So how can we draw that? I know that's so difficult.
So done. So we can take photo. So should I send it on the group?
That even I'll be able to do it. It's okay, I'll do it later. It's okay, I'll send it on your WhatsApp.
So should I send it? I already clicked it.
Okay. If you want, you can send it. We'll just go ahead.
Okay.
It is used to separate two or more substances present in a liquid or for purification of water. The apparatus used for distillation is shown here. Let us see the demonstration. Take some salt water in a retort and heat it till the water gets converted to steam. The steam is collected in the beaker, which is connected to the retort as shown here. The steam condenses into drops of water and the salt is left behind in the retort.
Yeah. That was distillation. Okay, so these are the methods for soluble, solid plus liquid. Even it is applicable even for two miscible liquids. Okay, so the method of distillation can be used even for two miscible liquids, that is two liquids that mix up with each other, whose boiling point difference is more than 20 degrees Celsius. Okay, example is alcohol plus water. Both of these liquids get mixed up with each other. Alcohol is having boiling point 78 degrees Celsius. Water is having boiling point 100 degrees Celsius. You can see the difference in boiling point is more than 20. Therefore, this method of distillation can be used even for those two liquids which are miscible, that is, which mix up with each other. I just want you to copy down what I have written just now. Next part. Okay, if the two liquids are having boiling point difference less than 20 degrees Celsius, so two liquids whose boiling point difference is less than 20 degrees Celsius, the method that is used over here is this method is fractional distillation. The only difference over here is something else is added over here which is known as fractionating column. This is what you are able to see in the picture. So this kind of distillation will be done. Okay, this column which is there is known as fractionating column. This is the actual picture that is shown, okay, which is about a few floors building. This is especially used in petroleums. Okay, crude oil is how this is going to get separated. So this method is going to be fractional distillation.
So you're showing us the video.
Wait 1 minute.
Fractional distillation is used to separate a mixture of liquids which typically have boiling points which differ by only 25 degrees or less. This is the distilling flask which contains our mixture of liquids. This is firstly clamped into a heating mantle. We then place a fractionating column into the neck of the flask. There are a number of different types of fractionating column that you may use. It's wise to insulate the fractionating column with some lagging wrapped in foil, particularly if you're working in a fume hood where the air draft may cool the column down and slow down your distillation. Above the fractionating column we have a standard still head, and into this we've placed a thermometer which will allow us to measure the boiling points of the different liquids, or fractions as we call them. A condenser is connected with water flowing steadily from bottom to top, and this is followed by a receiver. We will collect the fractions using a piece of glassware called a pig, which can be easily rotated, allowing us to collect the next fraction. As the contents of the distilling flask begin to boil, it's important to watch the thermometer. The temperature will rise before reaching the boiling point of the first fraction. This will be evident when the temperature stops rising, at which point you should collect the first fraction. Here you can see the fraction condensing around the bulb of the thermometer before being collected via the pig. You should continue to collect this fraction until you see a change in the temperature on the thermometer, at which point you can rotate the pig in readiness for the next fraction.
When the temperature
These steps can be repeated until all the
You will
fractions
rotate
have been
it.
collected.
Okay, that was fractional distillation. This method is used for two miscible liquids whose boiling point difference is less than 20 degrees Celsius. Evaporation, simple distillation, fractional distillation. Okay, crude oil, this is the picture that I had shown you. Okay. Next part is chromatography. This is paper chromatography. You just put one drop and then the different parts of the mixture of that liquid which is there will just move in circles outwardly. and then you are going to get different rings, different substances will get separated. I'm just going to show you an experiment even on chromatography as well.
This video shows an example of a chromatography experiment. The goal of the experiment is to separate the different pigments of ink which are present in a wet erase marker, which we'll see right here. So a vis-a-vis marker is wet erase, which means that the pigments are water soluble. We'll start our experiment by drawing a line with the marker on the chromatography paper. Then what we want to do is insert that chromatography paper into a beaker with a small volume of water in it. We can see that the water will start to rise up the chromatography paper because of capillary action. You'll note this happening very quickly because this is 16 times speed playback. We can see that the ink, which originally looked black, is starting to separate into different colors. This is because the different pigments have different properties. Some of them are heavier, some are lighter, some are more soluble in water, some are less. Because of these differing properties, all of the different colors are going to travel at different speeds. And by the completion of our experiment, we should see some very nice separation of the different pigment colors. Now, to do analysis of our results, what we're going to want to do is to measure the distance traveled by each pigment. Let's pause here for a moment. So I want to measure the maximum distance traveled by the water and then by each different pigment starting at the line drawn on the paper. To be fair, we should be comparing the distance traveled by the water starting from the same point where the pigment started traveling. So we'll measure all of our distances starting at this point. Looks like the maximum distance traveled by the water reaches about to here, and then we can measure the maximum distance traveled by each of the different pigments. Let's continue our playback.
This is what is known as RF value. We are also going to draw the diagram.
So we have to copy this diagram.
Yes. This is the definition of RF value. Okay. Headphone लगा दिया ना? Okay, so this is the distance traveled by the solvent front, that is the liquid front. That is the maximum distance traveled, and whatever the sample is there or the pigment that is there, that is the distance moved by the pigment. So here for A, the RF value is going to be, okay, distance moved by sample A, that is pigment A, is going to be 4 centimeters divided by the total distance covered by the solvent front is 10 centimeters. This is going to be 0.4. Same way you can also find the RF value for B. Distance moved by sample of B is 6 centimeters divided by the distance moved by the solvent front, that is from here to here. This solvent front has moved by the distance of 10 centimeters. So for B, the RF value is going to be 0.6. I also want you to write down those values that I have calculated for each of these samples. The diagram is also very important. Where is Yashi? She didn't come for the class today.
Sir, charger's broken.
Okay. Yeah, everyone is finished.
No, sir, 1 minute.
Okay.
Done, sir.
Yeah, let's go ahead. Then we are going to later take past paper questions from these. Chromatography has very important uses. Okay, the most important of them of important use of this is even when the sample is very small in amount, still you will be able to carry out the separation. The foodstuffs contain different kind of amino acids. 20 different amino acids are required for our body to stay healthy. All these kind of different amino acids can be separated by using this technique of chromatography. Okay. The substance that is traveling is also known as locating agent instead of solvent. Okay. You don't have to learn the names of these all substances. This is the definition of RF value, distance moved by the sample or pigment divided by distance moved by solvent. Even it is used in detection purposes in crime when very small amount of sample is available. This all is additional part. So that ends this particular topic. Okay. These all calculation of RF values and all this will be coming over here. We can solve these questions tomorrow. Okay, tomorrow our time will be 7:30.